Chemistry. This is lesson 7 in the foundations unit. It's our first lesson dealing actually with chemistry, and it's on the basic atom. So electrical force is the single most important factor in all of chemistry. The key point about electrical force is that positive attracts negative and negative attracts positive. Positive repels, pushes away positive, and negative repels, pushes away negative. It's a simple concept, and it's one that we're going to be dealing with almost every day in this class for the rest of the course. An element is pure matter that cannot be divided into simpler substances. An atom is the smallest piece of an element. When you cut an element as far as you can, you have an atom of that element. There are 90 naturally occurring elements plus about another 28 that were created by scientists in labs. All matter in the universe is made of these 90 elements. Below are 5 naturally occurring elements. Carbon, gold, neon, which is a gas, uranium, which is the largest natural element, and mercury, which is one of only 2 elements on the periodic table that is liquid at room temperature. Perhaps the most versatile in that list is carbon. It can be anything from coal, which you burn for energy, to the graphite in your pencil, to diamonds. It also makes up the backbone, the chain of virtually every organic and biological cell. So your body is made up largely of carbon as well. Now, the 90 number is sometimes you'll hear 92. Is uranium, which is the largest, is number 92. However, 2 of the elements on the periodic table are unstable. They're highly unstable and therefore don't really constitute elements that would actually exist in nature for very long. But 92 is also an acceptable number as to the number of elements. So just as the 26 letters of the English language can be arranged to make millions of words, the 90 elements can be arranged and combined to make millions of different substances called compounds. A compound is a substance containing 2 or more elements. There are up to 50 million chemical substances, and I've actually read somewhere that there's billions in the universe. The number is not important. I think the point to take away is that there's a limited, very finite number of elements, about 90, and yet they can make almost a countless number of compounds. So water, consisting of the elements hydrogen and oxygen, is the most common compound on Earth. The periodic table is a list of all the elements in the universe. The periodic table is the centerpiece of the study of chemistry. So what we'll learn in this class is how the periodic table is organized. Why does it have this, slightly unusual shape? It's not just a list going from top to bottom or side to side. There's a reason why it has this shape, and that's part of what you're going to learn as you go through this course, is why it has that shape, why elements are placed where they are. So Dmitri Mendeleev is credited with creating the periodic table. He did much of his work by laying out cards while riding trains around Russia. So the 2 main divisions are metals. That would include what you see on the far left, the alkaline earth, transition, and then as you move to the right, the transition metals, and then the other metals. So about 2/3 about 3/4 of the periodic table is metals. Then the nonmetals. Nonmetals would include the halogens, the noble gases, and the ones that you see in orange in the upper right-hand corner. Now the nonmetals are very small in number compared to metals. So you might think that they're not as important, but they're actually are the elements that we're going to study the most in this class. Your body is made up pretty much entirely of nonmetals. So we're going to study those in the upper right-hand corner quite a bit. And then there's kind of a border between the metals and the nonmetals called the metalloids, and that's because they contain characteristics of the metals and the nonmetals kind of combined together. And it's metalloids, also called semimetals or semiconductors, that are used to make chips that go in your cell phone, in computers, and in electrons. That would be, for example, silicon or germanium. But the real focus of this class, more than anything else, is going to be the nonmetals, and as well as the metals. So the first two columns and the last 6 columns of the periodic table are called the representative elements, or group A elements. And these have a special place, and we're going to talk more about them than any other. We'll find out what the significance of those elements is. So in about 400 BC, a Greek named Democritus developed the idea that there was a smallest piece of matter that could not be further divided. The Greek word atomos means indivisible, which means it cannot be divided. So the smallest piece of an element is called an atom. In about 1800, English chemist John Dalton developed his atomic theory describing atoms and how they combine to form compounds. So it is Dalton, by the way, who came up with the name atom. So 1, all elements are composed of indivisible atoms. 2, atoms of the same element are identical. Atoms of one element are different from those of another element. 3, atoms of different elements can combine in whole number ratios to form compounds. That is, combinations of 2 or more elements. And 4, chemical reactions are when atoms join, separate, or are rearranged. Atoms of one element cannot be changed into another element. Now, Dalton came up with all of this long before they had actually really discovered what an atom looked like, what it was made of, how it interacted with other atoms. But he came up with this theory through his observations, roughly in around the year 1800. So the following are some notes concerning Dalton's 4 principles. So 1, all elements are composed of indivisible atoms. So Dalton developed these 4 postulates 100 years before the discovery of protons, neutrons, and electrons, to be discussed in the next lesson. Dalton is correct that atoms cannot be divided into simpler substances. Atoms of the same element are identical. Atoms of one element are different from those of another element. That's mostly true, but Dalton did not know the concept of ions and isotopes, and again, that's going to be discussed in the next few lessons. The following are some notes concerning Dalton's 4 principles. So number 3, atoms of different elements can combine in whole number ratios to form compounds, combinations of 2 or more elements. So this is completely correct. An atom cannot be divided. That's why it's possible to have H2O but not H1.5O. It has to be a whole number of atoms that combine to form new elements or new compounds. And 4, chemical reactions are when atoms join, separate, or are rearranged. Atoms of one element cannot be changed into another element. The first sentence is completely correct. In fact, it's the definition of chemistry and what a chemical reaction is. It's a rearrangement of atoms. So rearrangements of atoms is the definition of chemical reactions. Atoms can, however, be changed into other elements. This occurs during nuclear reactions, which involve changes in the nucleus. So we'll talk a little bit about nuclear chemistry, but mainly chemistry is the study of taking whole atoms, not breaking them apart, and putting them together to form new substances. And that takes care of this quick lesson to introduce you to the concept of the atom, and we'll study it in more detail in the next lesson.